Now illustration number 14. Illustration number 14 asks which term of the progression 3, 10, 17, etc. will be 84 more than its 13th term. So we have a given AP which with the terms as 3, 10, 17 and so on, and we have to find the term which is 84 more than the 13th term of the AP. So as the first step of the question, we will first find out the 13th term of the AP. Here the first term A is 3, the common difference D would be 10 minus 3, that's 7. So to find out the 13th term, what do we do? A plus 13 minus 1 into D, which is 3 plus 12 into 7, which is 3 plus 84, we get 87. We have to find a term which is 84 more than the 13th term. So 84 more than the 13th term would be 84 plus A13, which is 84 plus 87, which is 171. So we have to find out which term of the given AP is 171. So now our AN changes to 171. We have A as 3, D as 7. So AN equal to A plus N minus 1 into D, or 171 equal to 3 plus N minus 1 into 7. We bring 3 this side, it will be 168 is equal to 7, N minus 1, 7 cancels out, we get 24, or N is equal to 24 plus 1 is equal to 25. So 171 is the 25th term. And what is asked in this question? It is asked that which term of the progression is 84 more than the 13th term. So the 84 more than the 13th term is 171, and 171 turns out to be the 25th term of the progression. Hence the answer would be 25. So the 25th term of the sequence of the given progression is 84 more than the 13th term. The 13th term was 87. 84 more than the 13th term would be 171, and using 171 as AN, we have been able to find out the N value of N. So N is the value of N, or the nth term, which is 84 more than the 13th term. This is how we solve this question. Let's look at the next question. Next question is find the 31st term of an AP whose 11th term is 38 and 16th term is 73. For finding out any AP, we need to find out the first term and the common difference. First term and the common difference. So there will be two variables. There are two values that you have to find out. Since you have to find out two unknown values, you will need two equations. So we have two different conditions. We know that the 11th term is 38 and the 16th term is 73. How do we approach this question? Let us assume that the first term would be A and the common difference would be D. So what do we have? We have the 11th term as 38. So A11 will be, this is A11 will be A plus 11 minus 1 into D, which is given to be equal to 38. So we have A plus 10D equal to 38. We call this equation 1. It is also given that the 16th term is 73. How do we write the 16th term? It's A plus 15D. It will be 16 minus 1, so it will be 15. I have written it straight away, and this is equal to 73. This is equation 2. If you subtract 2 from 1, what do we get? This from this. A will cancel out. 15D minus 10D will be 5D, and 73 minus 38, 35. So from here we get D equal to 7. When we get D equal to 7, we substitute in 1 and we get A plus 7 into 10 equal to 38, or A is equal to 38 minus 70 is equal to minus 32. So we have to find the 31st term now. We now know what is D. We now know what is A, that is the first term. Can't we write the 31st term? It's very simple. The 31st term will be A plus 30 into D. A is minus 32 plus 30 into D is 7. So you get minus 32 plus 2, 1, 0. And how much will that be? So it will be 188. So the 31st term of the given AP would be 188. Let's relook at it. We have to find the 31st term of an AP given that the 11th term of the given AP is 38 and the 16th term is 73. Now, we assume the first term to be A and the common difference to be D. So the 11th term can be written as A11 and it will be equal to A plus 11 minus 1 into D, and it is given to be equal to 38. So A plus 10D is 38. Similarly, the 16th term can be written as A plus 16D and it is equal to 73. When we subtract these two equations, A will cancel out. 15D minus 10D you will get 5D on the left hand side, and on the right hand side you will get 73 minus 38, which comes out to be 35. So the common difference D would be 7. Once you have obtained the value of D, using equation 1 we can find the value of A. How? A plus 10 into 7 is equal to 38. So we get A is equal to 38 minus 70, that's minus 32. Once we have obtained the first term and the common difference, we can find any term of the given AP. Now we have to find the 31st term. So A31 will be equal to A plus 30D. A is minus 32 and D is 7. So it's 30 into 7. We get minus 32 plus 210, which is equal to 188. Is it right or am I wrong? I think it's 178. It will come out to be 178. I think I'm a bit weak with the calculations, but you shouldn't be. So it's 178. 210 minus 32 would be 178. So this is how you obtain the value of the 31st term. So here we have looked at a few very interesting illustrations. Let's see how the chapter progresses further. So now we have to find out how many 3-digit numbers are divisible by 7. So for these types of questions, we have to find out the first number. The first number that will be divisible by 7, a 3-digit number that will be divisible by 7 will be 105. You can do a simple calculation and find out 100 is not divisible. The first number that you will get is 105. Second would be 112. This would go on, and the last number would be less than 1000. So 1000, if you try to figure it out, the last 3-digit number that is divisible by 7 will be 994. So the first number and the last 3-digit number we have to find out which is divisible by 7. We observe that this will turn out to be an AP with common difference of 7. So we have A equal to 105, which is the first term. The common difference D is equal to 7, and AN, which is the last term, has 994. Now we have to find how many numbers are there. So we basically have to find out the value of N. How do we find it out? It's AN equal to A plus N minus 1 into D. We have AN as 994, which is equal to 105 plus N we don't know. So this is what we have. So 994 minus 105 is going to be 9 into N minus 1. How much would this be? We subtract this 894, 889. I hope I am solving it correctly. Let's see. I hope I am right. So N will be 127 plus 1, which is 128. So there will be 128 3-digit numbers which will be divisible by 7. Let's see it again. How do we solve it? We have to find out how many 3-digit numbers are there which are divisible by 7. The first 3-digit number that is divisible by 7 by simple calculation can be figured out, and it is equal to 105. Obviously the next number divisible by 7 will be 7 added to 105, so it will be 112, and so on and so forth. What will be the last number? The last number will have to be less than 1000. So we again go and back calculate to see which is the largest number that's close to 1000, not more than 1000, that's divisible by 7, and we can easily figure it out that it is 994. So when we write these numbers, we find out that it basically forms an AP with common difference 7. The first term being 105 and the last 3-digit term that's divisible by 7 being 994. So A is 105, the common difference D is 7, and AN, which is the last term, is 994. So can we find N? Yes, we can find N using the general term formula of AN equal to A plus N minus 1 into D. AN is 994, we have A equal to 105, N we have to find it out, D is 7. We do a simple calculation and we find out that N is equal to 128, that's 128. So we can say that there are 128 numbers, 128 3-digit numbers that are divisible by 7. Now, coming to the next question, which is a word problem based question. It says a sum of rupees 1000 is invested at 8% simple interest per annum. PA is per annum and SI is simple interest. Calculate the interest at the end of each year. Do these interests form an AP? If so, find the interest at the end of 30 years. So it is basically a problem that's been asked in AP, but it also involves concepts of the commercial arithmetic that you might have studied in earlier classes, in class 8 probably. So what was the formula for SI? SI was PTR by 100. P is the principal amount that's invested, T is the time duration in years, and R is the rate of interest per annum. So at the end of first year, interest at the end of year 1 will be what? 1000, time period will be 1, the rate is 8 per year by 100, which is equal to 80. So the interest is rupees 80. Interest at the end of year 2 will be 1000 into 2 into 8 by 100, rupees 160. The principal remains the same, 1000. The time period changes. So at the end of the year 2, the time will be 2 years and the rate of interest is 8% per annum. The principal remains the same. Similarly, the interest at the end of year 3 will be rupees 240. If you calculate, you put T equal to 3, you will get 240. So we are calculating the interest at the end of each year. Do these interests form an AP? This is the first year interest, this is the second year interest, this is the third year interest. The common difference, if you see for the interest, it always comes out to be 80. So the common difference is a constant fixed number, and hence the interests at the end of each year indeed form an AP, and the terms of the AP would be 80, 160, 240. What will be the next term? It will be 320, and it will continue. Now the question asks, so the first part of the question is solved. Do these interests form an AP? Yes, they do form an AP with common difference equal to 80 rupees. If so, find the interest at the end of 30 years. At the end of 30 years, so this is the interest at the end of 1 year, second year, third year, fourth year, and so on. So here N will be 30. The first term A will be 80, common difference D will be 80, and we have to find out AN, that is the interest at the end of 30th year. Let that be AN. What will AN be? It will be A plus N minus 1 into D. We have to find interest at the end of 30 years. So we have to find the 30th term of this given AP. And the 30th term of this given AP will be when n equal to 30. So an is equal to A plus n minus 1 into D. What do we get? 80 plus 29 into 80. We take 80 as common, so it will be 1 plus 29. That's 30 into 80. That's 2400. So the interest at the end of 30 years will be rupees 2400. I hope you got how we solved this question. The first step was finding out the interest at the end of each year by using the formula for simple interest, which is P into T into R by 100. Now interest at the end of year 1 will be 1000 because amount of 1000 was invested. So principal amount is going to be 1000. The time at the end of 1 year will be 1, rate 8 divided by 100. So we get the interest as 80 rupees. The interest at the end of year 2 will be principal into time is 2 years into rate divided by 100, which is equal to rupees 160. Interest at the end of year 3 will similarly obtain it as 240. So we observe that the interest at the end of each year come out to be 60, 80, 160, 240, 320 and so on. Now to figure out whether this is an AP or not, we find out the difference between any two consecutive terms. It has to turn out to be a constant number, fixed number. So 160 minus 80 is 80, 240 minus 160 is 80, 320 minus 240 is 80. So the difference always remains as 80. Hence, the interests at the end of each year form an AP with common difference 80. Once we know that the interests form an AP, we can find out the interest at the end of any year using the properties of an AP. So we have to find out the interest at the end of 30 years. So these are the interests at the end of each year. So the interest at the end of 30th year will be the 30th term of this given AP. So we have assumed n equal to 30. N is the number of terms that we have to find. A, the first term is 80, that is the interest at the end of the first year. The common difference is also 80 as we figured it out. Here it is 80. And AN we have to find out. We have to find AN, which is the interest at the end of A30 is the interest at the end of 30 years. What will it be equal to? It will be equal to A plus n minus 1 into D. A is 80, n is 30, n minus 1 into D is 80. We simplify it and we obtain that A30 or the interest at the end of 30th year is rupees 2400. So we can also apply arithmetic progression to figure out, to solve problems related to commercial mathematics or to the number theory. So arithmetic progression will have wide range of applications, and through problems we will be seeing how we can approach